Hey, 7th graders, continuing to look at probability today. We're looking at lessons 10 and 11, conducting a simulation to estimate the probability of an event. So this will be a lot easier if we were together, but we can still do the best we can not together. So to design a simulation, you first need to identify the possible outcomes. So that's one step. Then decide how to simulate them. So using coins, number cubes, cards, spinners, colored discs, random numbers. Sometimes multiple of these will work. Other times you might only have one option or two options. Step 3, specify what a trial for the simulation will look like. And then 4, what a success and a failure would mean. And then make sure you carry out enough trials to ensure that the estimated probability gets closer to the actual probability as you do more trials. There is no need for a specific number of trials at this time. However, you want to make sure to carry out enough trials so that the relative frequencies level off. Okay? So, suppose that a family has 3 children. To simulate the genders of the 3 children, the coin or number cube or a card would need to be used 3 times, once for each child. For example, 3 tosses of the coin resulted in heads, tails, representing a family with 2 boys and 1 girl. So heads is boys, tails is girls. Note also that HTH and THH also represent 2 boys and 1 girl. So just because you got one thing one way doesn't mean that that's the only option. Okay, so suppose that when a prime number, P, is rolled on the number cube, it simulates a boy birth, and a non-prime number, N, simulates a girl birth. Using such a number cube, list the outcomes that would simulate a boy birth and those that simulate a girl birth. So outcomes for a boy, 2, 3, 5, those are the prime numbers. 1, 4, 6 are the not prime numbers. So their births are equally likely. Okay, next, calculate the theoretical probability that a family with 3 children will have exactly 1 girl. So list the possible outcomes for a family with 3 children. For example, one possible outcome is BBB, all boys. So we have BBB, BBG, BGB, GBB, BGG, GBG, GGB, GGG. Wow, that was a lot. Okay, so assume that having a boy and having a girl are equally likely. Calculate, again, the theoretical probability that a family with 3 children will have exactly 1 girl. So each is equally likely. There's 3 different ones that are 1 girl. So out of 8 options, it's 3/8 or 0.375 theoretical probability of having exactly 1 girl. Okay, moving on. In a group of more than 12 people, is it likely that at least 2 people, maybe more, will have the same birth month? Now suppose that the same question is asked for a group of only 7 people. Are you likely to find some groups of 7 in which all 7 people have different birth months? So our first question is, what might be a good way to generate outcomes for the birth month problem? Coins, number cubes, cards, spinners, colored discs, or random numbers. So you need 12 outcomes because there's 12 different birth month options. So you could use cards and label them with the birth months. You could use spinners and have 12 equal sections. You could use colored discs and have 12 different colors. Or you could have a random number table where you would use 2-digit numbers, so like 0, 1, 0, 2, all the way up to 12. Okay, how would you simulate one trial of 7 birth months? Well, if you use the discs, you'd put the 12 discs in a bag, shake it, choose a disc, replace that, and do it 6 more times. It's important to replace the disc or whatever you're using because you still need the same opportunity for each of the outcomes to be rolled or selected or however it works. So how is a success determined? A success would be at least 1 match. So at least 2 of the people in the 7 have the same birthday. So at least 2 of the 7 trials are the same. Okay, that was a lot. And I promise you it would have been a lot easier if we were able to do it in person. But your Edmodo questions for lessons 10 and 11 is your assignment. A lot of what I'll be asking is just these questions. So what would be a good way to generate them? So like what would you use? How would you simulate it? Possible question there. And then how is a success determined? So in this case, a failure would be then that 2 of the same were not chosen because you want 2 of the same. So please just do your best. Absolutely let me know if you have questions. And that's it for today. So have a wonderful day. Once again, if you haven't seen the science video, or if you have, please remember you have testing tomorrow. If you have questions or your parents do, let me know.